So, last time we dove deep into storing network data in lists and dictionaries, which is awesome, right? But there's this one huge problem we kind of glossed over, a problem that every single person hits when they start scripting. Well, today we're going to solve it.
Think about it. You run your script, it connects to devices, gathers all this amazing data, you build the perfect Python list. And then? It's done. The script finishes. What happens to all that hard work you just did?
Poof. Gone. Vanished into thin air. Every variable, every list, every dictionary, it all just disappears. Why? Because it only ever lived in your computer's short-term memory.
Today, we're going to give our scripts a memory. We're going to teach them how to read from and write to the real world using files. Honestly, this is the skill that takes you from just writing scripts to building real, powerful automation. Okay, so where do we even begin? Well, the most important thing to learn right out of the gate is the modern, safe way to handle files in Python. You can think of it like a self-cleaning tool for your code, which is pretty cool.
The magic command here is with open. Now, as you can see, this is the modern, safe way to do things. See, back in the day, you had to remember to manually close every single file you opened. If you forgot, you could easily corrupt your data. The with statement completely automates that cleanup for you, guaranteeing your files are always closed safely. It's a lifesaver.
And when you open a file, you got to tell Python what you're planning to do. These three modes are the ones you'll use 99% of the time. R is for read, that's the default. W is for write, but you have to be careful with this one. It will completely wipe the file clean before it writes. And A is for append, which is much safer. It just adds your new data to the very end of the file.
Seriously, if there's one habit you build from this, it's to always use with open. It's one of those things that immediately tells people you know what you're doing. It's clean, it's professional, and it'll save you from so many headaches down the line.
All right, enough theory. Let's actually put this into practice. We'll start with something super common, just working with plain old text files. Perfect for things like lists of IPs or for saving config backups.
So imagine you have this simple file, ips.txt. It's nothing fancy, just a list of device IP addresses, one on each line. Our goal is simple. Get this list out of the file and into our Python script so we can actually use it. And the code is actually pretty straightforward. We create an empty list, we open the file, and then we loop through it one line at a time. Now here is a super critical step, that .strip method. Every line in a text file ends with an invisible new line character. If you forget to strip it off, you'll get weird bugs later. So we clean each line, then we add it to our list.
And check it out, that's the result. That static, boring text file has been transformed into a living, breathing Python list. It's no longer just text, it's actual usable data inside our program ready for us to loop over and connect to those devices.
Okay, so that's reading. What about the other way around? It's just as easy. We can take some data that's already in our script, like this router config here, and just write it out to a file. We open a file using W for write mode, and boom, we've just created a config backup. The data is now saved.
Now, simple text files are great and all, but what about more structured data? Like a real network inventory. This is where CSV files come in, and let me tell you, this is the key to building truly scalable automation. Just look at this. A CSV file is really just a text file that's pretending to be a spreadsheet. The first row gives us our headers, hostname, IP address, model location, and then every row after that is a record, a specific device in our network. This structure is absolutely perfect for automation.
So how do we handle this? Well, Python has a built-in CSV module, and inside it is this magical little tool called DictReader. What it does is amazing. It reads the CSV, it automatically sees that first row and says, aha, those are the headers. And then it turns every single row after that into a perfectly structured dictionary. It's brilliant.
And this right here is the biggest takeaway of this section. The CSV.reader effortlessly turns your inventory file into a list of dictionaries. And if you remember from our last explainer, that is the absolute gold standard, the ultimate data structure for network automation. Okay, so we can read files, we can write new files. But how do you change data that's already in a file? This is a really common question, and it trips a lot of people up because you don't really edit a file directly. Instead, you have to learn a specific pattern.
And that pattern is called read, modify, write. It's as simple as it sounds. First, you read the entire file into your script's memory, say into that list of dictionaries.
Second, you modify the data while it's in memory using all your Python skills. And finally, you write the entire updated dataset back out to a file, completely overwriting the old one.
Here's what those last two steps look like in code. The modify step is pure Python. We're just changing a value in our list of dictionaries. Easy. Then, for the write step, we use another cool tool, the CSV dict writer, which does the reverse of the reader. It takes our list of dictionaries and writes it all back out into a perfectly formatted CSV file.
Let's just let that sink in for a second. This read, modify, write pattern is absolutely fundamental. Once you get this concept down, you can programmatically update any structured data file, which is an unbelievably powerful skill to have.
And just like that, you've literally gained a superpower. Your scripts are no longer forgetful little programs. They can now interact with the outside world. They can remember information between runs, and they can save their work.
I mean, think about what we just covered. You now know the safe, professional way to handle files. You can pull data from simple text files, save config backups, and, most importantly, you can read and update a structured network inventory. You've officially connected files in the real world to powerful data structures in your code.
And this is all building towards something much bigger. The file skills you learn today are the foundation. Next time, we're going to put it all together. We're going to add loops and logic to build a script that actually reads this inventory and starts making intelligent decisions based on the data. So, I'll just leave you with this one question. You now know how to give your scripts a memory. You can read data from the world, and you can save data back to it. The possibilities are suddenly wide open. So, what are you going to build first?